Hi, this is Mary Hansen, and this presentation is on interpreting SPSS output for a regression example using simple linear regression. The problem is, 7 boys take a 20-item exam to measure impulse control and are rated by their teacher on aggressiveness from 1 equals very non-aggressive to 10 equals highly aggressive. Can the boys' aggressiveness be predicted from the impulse control scores? In this example, we have 2 measures on each boy in the study, and the goal is to predict the boy's aggressiveness just by knowing their impulse control score. When we want to look at a regression analysis, the first step will be to construct a scatter plot of x versus y. In this example, we see in this scatter plot of x versus y that the data have a negative relationship, where higher scores on impulse control reflect lower aggressiveness, and lower scores on impulse control reflect higher aggressiveness. Again, that is indicating a negative relationship. Because the data look as though they fall in a fairly tight ellipse, we estimate that relationship to be a fairly strong negative relationship. If we want to compute the value of the least squares regression line, we need to look at the SPSS output. The SPSS output under the coefficients table provides the slope in the second row and the intercept in the first row. The slope is negative 0.834 and the intercept is 14.487. We can use those values when we write the equation of the least squares regression line. The equation of the line is y hat, denoting that this is a regression line rather than a regular line, equals negative 0.834x plus 14.487. Next, we want to sketch the line on our plot. We have 2 options for doing so. One option is to use the function in SPSS that sketches the line right on the graph. The second option is to plot the points on our own. In order to plot a line, we need 2 points that fall on the line. So, using our regression line, we could choose a value such as x equals 10, plug in the 10 and get the corresponding y value, and plot that value on our curve. We could do the same thing for x equals 14, get the corresponding y value, and then connect the dots. In order to determine if we can use that regression equation to predict the value of aggressiveness from impulse control, we need to look at a few pieces of information. One is the correlation coefficient. This table shows the Pearson correlation coefficient for the correlation between impulse control and aggressiveness, and we see that the correlation is negative 0.867, again indicating a strong negative relationship. Another piece of information that can tell us about the quality of the prediction is the R-squared value. The R-squared value is given in SPSS in the model summary table. The R-squared in this case is 0.752. R-squared can be interpreted as a percentage. We say that 75.2% of the variation in our y variable aggressiveness is explained just by knowing the impulse control scores. Think about it this way. If we could explain 75% of the behavior in boys or girls or our child just by knowing a score on a test, wouldn't we be happy with that? This coefficient of determination indicates that we are working towards a high-quality regression equation. In order to assess the fit of the model, there are 3 additional pieces of information that we should look at. First, we should look at a scatter plot of the residuals versus the fitted values. When we look at this plot, what we should see is a random scatter of points. If you draw a line across 0, what we want to see is data that looks like it's fairly evenly distributed as we look across the scale. We don't want to see any patterns in this data. In this example, it looks like a fairly random plot. indicating model data fit. Next, we need to make sure that the error terms are normally distributed. We can do that through two pieces of information that SPSS provides. One is a histogram of the residuals, and the other is a normal probability plot of the residuals. Looking first at the histogram of the residuals, there is some question about the normality of the residuals. It looks like a fairly uniform plot. However, with only 7 data points, it is difficult to establish normality in a data set. Looking at the normal probability plot, what we want is to have the data fall right along this solid diagonal line with very little deviation from it. We see only small deviations from this line. While we don't have strong evidence that the error terms are normally distributed, we have enough evidence that the model does fit the data. Therefore, we can use the model to predict aggressiveness from the impulse control scores. As an example, if we want to predict the aggressiveness score for a student whose impulse control score is 10, what we want to do is take our regression line and plug in a value of 10. When we plug in a value of 10 into the regression equation, we get negative 0.834 times x plus 14.487, which is negative 0.834 times 10 plus 14.487. Plugging in the y value, we get approximately 6, so we would estimate that the aggressiveness score is 6.1. If we want to predict the aggressiveness score for a boy whose impulse control score was 20, we would plug 20 into the equation. Plugging 20 into the equation actually gives us a negative value for the impulse control. We know that that is not a possible value of our impulse control score. One problem with using the regression equation outside of the scope of the data is that it's not always appropriate to extrapolate. Extrapolation, again, is to use the prediction for values of x that were not included in the original data set. In this case, we certainly wouldn't be able to use the score to predict higher values than 20, because that would be outside of the range of the data. 20 is in fact at our maximum range. In this problem, we have some issues with extrapolating, and we should note that if we do extrapolate and get a negative score for the predicted value, that it's not realistic that we have a negative score on our test because we do have a 0 minimum. This presentation is by Dr. Mary Hansen, and it is on interpreting the SPSS output from a regression analysis.